Okay guys, this is a very quick thing for chapter 6, talking about chemical equations and reactions. I did a couple of videos before how to balance equations and the types of reactions that there are. They're like about maybe 10 or 13 minutes a piece, and that's not a big deal. So, chemical reactions, basically it's a process, okay, where things can be changed, okay? We can talk about evidences, we can talk about the reactants and the products of the chemical reactions. So if we look at something like, let's just do it down here, O2 in the form of a gas plus 2H2 also in the form of a gas gets us to 2H2O. Here is a chemical equation, fairly straightforward. We've got O2 as a gas. Now remember the 2 here tells us that there are 2 oxygen atoms to this one oxygen molecule. So if we were to look at it from a perspective, it would look something like this. That would be our 2 oxygen atoms. And then we have 2H2. This is also in the form of a gas, and that's where the letter G comes in. Okay. And we know hydrogens are a little bit smaller, so what does that look like? It's going to look like this. Okay? So that's what it's going to look like. And then, of course, we end up getting the arrow where we have 2 H2Os, so we got basically 2 of these Mickey Mouse molecules, as everybody knows. So this is one way to look at a chemical equation, okay? And let's see what else I have moving on here. What about the evidence for chemical reactions? Think about heat, light being given off, a color change. Okay, explosions, those are great. Okay, and chemical reactions, they're either going to release or absorb energy. That's one of the things. Reactants do have to come together as well. And we talked about that they got to crash into each other. All right, we talked about a chemical equation. We looked at word equations. I did not make a big deal about word equations, but it's the same basic idea, okay, of taking these and being able to make chemical formulas out of them. I didn't really emphasize that much in class, so I'm not going to worry too much about that for the exam. Now, what about these symbols and what is it that they mean? Think of it as shorthand for writing up for chemical equations. It's part of the punctuation. Okay, so there's different things that they have different meanings. What would be really the most important ones? Well, the arrow, the plus, that would be kind of important. The G, the L, the S, and the AQ, those would be fairly important. Okay. A gas being produced, the arrow going up, the arrow going down, a precipitate, think a solid that's being formed like that lab that we did not so long ago before Christmas, where you were adding drops of different bottles to see what kind of a reaction you were going to get. If you had a positive reaction, you had a precipitate that formed and it probably turned milky white. That's what I'm thinking. Okay. We talked about the idea of reversible reactions, that reactions can go back and forth. We talked about that. We talked about heat being added to the reaction. That's where you see that little delta triangle that's there. Okay. So the big idea is we have to look at reactants and products. Well, what in the world is that going to look like? Well, when we look at reactants and products for an equation like this, then there are some things that we need to look at. Remember, the idea behind the reactant, okay, think of it as the ingredients. The ingredients that you have, perhaps like for baking. For example, if you were baking a pie, let's say it was an apple pie, you had apple and flour and egg and butter and sugar. All those would be like reactants. On here, you have the product. Now the product is your end result. This is what you're going to get at the end of the equation. Okay, sometimes you're going to get more than one product, so you can have products. Sometimes we're not so much interested in the material product. Sometimes we're interested in what the product is giving off, like light, for example. Think of the glow stick. You break it in the middle, you shake, 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 and you get a light. okay? I don't care about what's in the liquid or what the new liquid is looking like. I'm interested in the light that it glows, because yay, I can go to some kind of a, glow stick rave or something. Okay, then another way to look at this, can reactions go backwards? Yes, they can. They can in fact go backwards as well. So we can take water, we can apply electricity to it and break it into H2 and O2 gas. That would be a decomposition reaction where you're breaking things apart, okay? Whereas this is a synthesis reaction where you're putting things together and you're getting a result out of it. Okay, let's see. What other things did I have to go over with you guys here? I did talk about types of reactions in another video, so you guys are going to have to go look at that one up, okay? So let's take a look at this. Let's round this out. We're looking at the parts of a chemical equation. We looked at the reactants, which in this case, O2 plus 2H2, and I drew out their representations down here. We end up getting a product, 2H2O, where we get 2 water molecules as the result. So when we're talking about balancing a chemical reaction, also known as a chemical equation, we're balancing out these numbers, not these. These are called a coefficient. This is the, sorry, not coefficient. My mistake, it's Monday. Subscript. This is your subscript, this is your coefficient. Okay? This subscript cannot change, because if you change this from, let's say, O2 to O3, it's no longer the oxygen that we can breathe in, it's ozone. O3 is ozone, which is great for blocking out ultraviolet radiation, but if we were to breathe in O3, our bodies can't use it. And it's going to irritate our mucus linings, and we'll sit there and cry like little babies, because it'll bring tears. And I'm not talking tears of happiness. Okay, so reactants and products, okay, here is your coefficient. How many of these H2s do we have running loose? Okay, and these are our subscripts. And with that, ladies and gentlemen, you got the basics for a chemical equation. You also got to learn about the reactants have to crash into each other in order to have the reaction take place. Sometimes the evidence of chemical reactions, color change, light, heat, explosion, sometimes a precipitate. Remember, precipitate's a solid that forms. Think of that milky white stuff in the lab that you did before Christmas vacation. Yeah. Okay, guys, I hope this helps you out. Take it easy.